Good evening, my dear JEE warriors. This is your Captain Shreyas on the Vedantu JEE English channel. And here I am today to take some very important questions. And that too on class 12 syllabus because many of the kids right now are focusing on boards and they feel more attached and connected and relatable when you are seeing more of 12th standard syllabus related questions, practice, mocks, whatever, theory, revision. So, in a way, it will not deviate completely from your 12th standard plan and you will feel very much connected for your boards. And if you're a dropper, it really doesn't matter. For you, every single question that I solve over here is obviously very important. So, JEE Advanced is not very far because the time will fly like this, and after your April attempt you barely will have time. Yesterday only I made a strategy for cracking JEE Advanced and I have told it very clearly that don't skip JEE preparation whether it is mains or advanced in the months to come because you will feel disconnected otherwise. So let's stay connected. Let's crack some JEE Advanced questions. I don't have many questions because each question takes a lot of time in physics or even in maths that way, and it involves a lot of deep concepts. So let's have a look. They are not very difficult, but they are not very easy also, because I just want you to kickstart your journey for JEE Advanced today, right? Good evening. Hi Gokul, hi Santosh, hi Nitya, hi Simple, hi Vivan, hi Abdul. Welcome aboard. Good evening, my dear warriors. And if you are new to the channel, subscribe, and if you have already subscribed, like this video and share this video with all your friends. Thank you so much for liking. That was my quick intro. All right. Yeah. So let's start with some SCQ. Then I will go single correct questions, meaning only one option is correct. Yeah, these kind of questions look like mains questions, but they are a little tougher than that or lengthier than that. Then we'll do one match the following. Then we'll also do multiple options correct kind of questions also. Okay. So all kinds of pattern I have tried to keep today, and you will see how things change when it goes to MCQ. So here is your first question. There are two beads, each with charge Q and mass M, and are on a horizontal, smooth, non-conducting circular hoop of radius A. So imagine there is a ring kind of structure, smooth, massless, negligible, and there are two beads. Both are charged and having mass M, and they can slide on it. One of the beads is glued on that hoop. So one bead is fixed. Other bead, I think, is movable. And in fact, it is performing oscillations about the equilibrium position. The square of the angular frequency is how much? Okay, let's understand first what really is happening. Tell me one thing. If this is your hoop, and if you have two charges, where would they be ideally? Neglect gravitational force in this. Okay, neglect gravitational force, has no friction at all. So if any one charge, let's say, is over here, the other charge will try to run as far as possible because the charges are identical. So due to the repulsion, the other charge will be obviously at a diametrical opposite point. Yes, this would be a diameter. This would be the diameter, and this would be then the equilibrium position. Equilibrium position. That is the first thing you should understand, how the charges would behave in equilibrium. They will try to space out maximum distance, lowering their energy, maximum repulsion. So they will, try to be as far away as possible. Now, one of them is fixed, other one is movable or can slide on that ring or hoop. So if you move something here, then the potential energy will increase. There might be some kind of force of repulsion due to which it comes back. If it goes here, it will again try to come back to its equilibrium. It will try to restore. And that is the reason why that charge being displaced tries to come back over here. It restores back. It restores back to its original position, and because of which it performs oscillations. Because of which it performs oscillations, and that is what has been mentioned. And the question is, what is the square of the angular frequency? Now, what is the meaning of angular frequency? It is nothing but omega. So square of omega is asked, but this omega is not angular speed. So be very clear about it. So first thing what we did, we understood the question, we broke it down, we visualized it, draw a rough diagram, it's okay. Now this is not my final diagram because I have to think for oscillation, time period, etc. I need restoring force proportional to x, or torque proportional to theta, or energy proportional to square of the displacement, or a differential equation, or the equation of SHM. Something or the other I will need. So I feel doing it by forces will be much easier because I know Coulomb's force of repulsion will be there. Maybe a force will restore it, and that force somehow I can show it proportional to the displacement. Then my job will be done. Okay, did you understand how my flow will be and how I am thinking now, how I should approach the problem? Okay, I've not done anything yet. I've just broken the problem and I'm thinking what I need for omega or time period. I need force or torque or energy or equation of SHM or just the differential equation. None of the other things might be easy. This force method might look little easy. That's what I'm guessing. Let's see. So this is my fixed charge. This is my fixed charge. It cannot move anywhere. This is having a charge q and mass m. The other charge has been moved from its equilibrium position. Remember, this would have been its equilibrium position, and I move it by an angle of, let's say, theta. So this charge q and having mass m is right over here. Now the catch is that there will be electric force of repulsion, and the electric force of repulsion will obviously act along the line joining those two charges. So if you join a line, it becomes a chord. It is no longer a diameter. This is some disturbed position. It is not equilibrium. This is the disturbed position. This is your disturbed position. Okay, and in that disturbed position, the force of repulsion will obviously act somewhere like this over here. This would be the force of repulsion. Okay, now how much will that force be? For that I have an idea. I'll do one thing. If I join these two lines, these 2 points, the length of the chord, let me assume it as r. R is the distance of separation between these two charges, but that is very much different from the radius of the circle, which is from the center to this point or center to this particular point over here. Even this is also the radius. Radius and r are completely different. Small r is the separation between the charges along the line joining them. Oh, so maybe I need to find the relationship between them, and for that I will need one more thing, I believe, and that is maybe this angle, which will also be congruent to this angle because it forms an isosceles triangle. So let me assume that angle as phi. These are the base angles. This side will be congruent to this side. So the base angles, remember, small r will be the base. So the base angles will be equal. So some bit of geometry involved, marking involved, assumptions involved. First things first, how much will that force be? So that force which I am seeing will be Coulomb's constant, which is 1 by 4 pi epsilon naught multiplied by q1 q2, which is q multiplied by q, divided by square of the distance, which is nothing but q square divided by 4 pi epsilon naught r square. But right now I don't see how will it come back. So why is it trying to restore or trying to come back? The idea comes like this. If I extend that line from the center to the charge, if I extend that line from the center to the charge, immediately you start seeing what exactly is happening over here. That force has a tangential and a radial component. Can you see that, my dear students? It has a tangential and a radial component. There is a radial component along the radius, and this is basically the tangential component. So there are two components of it. This is the radial component. This is the tangential component. Radial component will give rise to normal. There will be a normal reaction from the hoop. Yes, there will be some pressure on the hoop because of that radial force. It will press against, the bead will press against that ring. So normal force might arrive. But the tangential force is the one which is making it slide. So that is acting like the restoring force. That is acting like the restoring force. So how much will that be? Well. See, the angle between this line and this line is phi. So the exact opposite angle will be over here, which is also phi. So this tangential will be the sine component, radial will be the cos component. So hence, I immediately see tangential component is f sine of phi, and I know what is f. I just need to figure out what phi is. Maybe from that I will get the answer. This is the restoring force. All right. Now, what might be the relationship between all these angles and r and all of that? Okay. So here is what I will tell. First of all, if you see in any triangle like this isosceles triangle, that small r will be 2 times the congruent sides, which is 2r, cos phi. This is a standard result you might have seen in trigonometry or mathematics, basically basic maths, or even in triangles, properties of triangles. Okay, is that right? Are you understanding how this relationship comes? Okay, in fact, this is a standard one, but if you want the derivation, guys, drop a perpendicular on the base of the isosceles triangle. This, if it is r, this is r cos phi, because the included angle is phi. This is the adjacent side, so it is r cos phi. This is also r cos phi. So r cos phi plus r cos phi is 2r cos phi. So that's how it comes. The base side is 2 times the congruent side into cos of the base angle. Okay, number one, maybe I will substitute it here. That's one thing. Also, what is the relationship between phi and theta? Okay, so for that, look at this particular angle. Maybe I will call it as psi. Okay, then this psi can be written down as 180 minus phi, because the sum of the angles are 180 degrees in a triangle. So for that isosceles triangle, psi will be 180 minus phi, which is nothing but 180 minus 2 phi. Also, the same psi will be 180, the total angle minus theta will be 180 minus theta, which means if LHS is same, RHS is same, so 180 minus 2 theta, 180 minus theta, that means theta will be equal to 2 phi. A lot of relationships that we have got, so maybe it's time that we use them. So let's start using it one by one. First of all, Ft will be f which is q square by 4 pi epsilon naught small r square. Now small r square means this square, so 2r cos phi whole square, and then the sine phi will be as it is. Next step will be q square as it is, 4 pi epsilon naught as it is, 2 square is 4, r square is r square, and you will have cos square phi, and on the top you will have just sine of phi. You will have just sine of phi. But phi is theta by 2. So let's use that. So it will become q square divided by 4 4s are basically 16 pi epsilon naught. Then you have r square. Sine phi I can write it as sine of theta by 2, and cos square phi I can write it as cos square theta by 2. I got it from here. Theta is 2 phi, so phi is theta by 2. Okay, next step, what should be my statement? 16 pi epsilon naught r square is as it is. Observe now, what is sine theta by 2? Well, because the angles are small, it was given to us in the problem for small oscillations. So theta is small. So sine theta by 2, I can approximately say, I can use approximate symbol, and I can say it is theta by 2. And cos of a very small angle is roughly 1. So So what I can do, this and all is not needed now over here. What will happen, guys? Observe carefully. Observe carefully. Okay. So my restoring force will become 2 multiplied by 16 is 32. So Q square divided by 32 pi epsilon naught R square multiplied by theta. That is what I'm going to get. Let's check this out. So 2 into 16 is 32. Cos of small angle is 1. I have used small angle approximation. Now what is theta? Well, see guys, you have moved it by a small amount. This is almost like a straight line. So if you literally think about it carefully, you will realize that this particular part almost is a straight line, that is x, and that x, which is the arc length, is the radius times of theta. Therefore theta is simply x by r. So instead of theta, why not put x divided by r and see what I get. So that force will be q square divided by 32 pi epsilon naught r cube multiplied by x. So my force is proportional to x. Can you see that, my dear students? So because it is proportional to x, therefore it is a simple harmonic motion. So whatever is there inside over here, whatever is there inside over here becomes the constant of force. So therefore my omega will become root of that constant divided by m, or basically omega square is k by m. Therefore omega square will be that k, which is nothing but q square divided by 32 pi epsilon naught r cube, and the whole thing divided by m. So this should be the answer. Q square divided by 32 pi epsilon naught r cube m, and let's figure it out. Yes, it is the right answer. Here the radius was a, so we can substitute the radius as a itself instead of capital R. Is that okay, guys? Understood? It's a beautiful question. Just to quickly give you a recap, what happened? We first figured out that the two beads at equilibrium will be diametrically opposite, and if I move it slightly, there might be a restoring force. So what I did was I moved it by a small angle, small displacement. I marked the angles, and by geometry I found the relationship between the distance and the radius for an isosceles triangle. Second important relationship, the base angles were related to this angle theta, which is the arc angle. And then I saw that the force was here making some small angle with the radius. So the tangential component was the component trying to bring it back over here, or else if all the force was radial, nothing will push it back over here. So once I understood tangential is restoring, I figured that component out and I substituted the force along with the sine phi value, and I used the substitutions which I did before. Finally, the moment I got force is proportional to the displacement, the inside constant will be k, the spring constant equivalent, and omega is root k by m. That's all we have done. Okay? Understood? How many of you got this? Did you love this question? Yes, no? Quickly let me know in the chat box. All right. Perfect. Shall we go to the next question then? Yeah? Okay, here comes the next question. A parallel beam of light strikes a piece of transparent glass cross section. The correct shape of the emergent wave will be how? It's a beautiful question. Okay, it's a very nice question. Some people might think, oh, sir, it is easy like this only, it will be, or like that only. But yeah, it has got some concept. Yeah, very good, Louis. Very good, Nitya. All right, let's have a look. Let me draw a big diagram. I think I have zoomed it over here. Yeah. So this is a parallel beam of light. It is a glass. It's not a reflector. So how do I do this? I feel we should break it down into two sections or three sections. First section is this part. And this is the next section. And this is the other section. Why am I doing it? Is because you'll realize now this almost behaves like a plano-convex lens. This also behaves like a plano-convex lens, and this one behaves like a plano-concave lens. And now, once you realize it is like plano-concave or plano-convex, things look easier. Yeah, the bulging part versus the flat part. So bulge part over here is convex, concave is the bulging inside. Okay, so what happens when the rays are parallel? They will obviously meet or not meet depending on whether it is concave or convex. So for convex, they should definitely meet. So they will start meeting somewhere over here like this, over here like this, just after the refraction. Okay, so this is how the rays will look like after emerging out, just emerging out from it. Versus for concave, they will start diverging. Yeah, for concave, they will start diverging like this. Yeah, they will start diverging like this. Yeah, perfect. So if you look at the wavefront, how will it look like? So this is how the wavefront will look like for concave, plano-concave. For plano-convex, it is like this because wavefronts are always perpendicular to the rays. So like this. Yeah, wavefront is always perpendicular to the rays. Remember, these were the rays. These were the rays, and this is nothing but your wave front. This is your wave front. So if you look at it, it is like this, and like this. Yeah, this is the correct option. Just check it out, like this, and like this. Can you see that, guys? Everyone? Yeah, it was first like this, then it was like this, and then it was like this. So this is the wavefront which will just come out after the refraction. Wasn't it a splendid question, guys? Based on kind of Huygens principle plus ray optics. Huygens principle, not so much, but it feels like it was. Yeah, but if you look at it like a ray optics question, it looks much easier, isn't it? I've seen such similar question in Physics Galaxy. Great. Yeah, it's a great book, man. If you have been following it, yeah, you can definitely use it. All right. Let's go to the next question then on your screen. Which of the following options represent the magnetic field at point O due to the current flowing in this particular wire segment? It's just a lengthy question. Otherwise, conceptually, it is based on the formula of a wire versus an arc. That's all. So there is this whole thing, and we have to figure out the magnetic field at point O. The dimensions, everything are given, and the entire wire frame is in the XY plane. So it is very obvious that the magnetic fields will be perpendicular to it. So that's why you will see all the options are in K cap direction, which is out of the board or inside the board. None of the options are in IJK. All right, so let's take a bigger diagram. Now in these kind of questions, always figure out there are some elements of wire which will not contribute in the magnetic field. Who are they? Let's figure that out first. All those wires, when extended, pass through that point where you are finding the field, will never contribute. Like for example, this is that point O. This wire, when extended, passes through that point, so it will not contribute at all. Same thing with even this wire will not contribute, and same thing with even this wire. So all these wires will not contribute. So I have shown it in red. I hope you can see it. Okay. So we will ignore those wires first of all. Okay. Let's ignore those wires first of all. Agree, disagree, everyone? Till this point, absolutely clear? Okay. Very nice. Now, what do we do next? We will first consider the straight wire. It is easier. So if you just consider this straight wire over here, I don't see any other straight wire because this is curved, this is also curved. So this is the only straight wire, and that is also of finite length. And you are standing over here at this particular point O. Okay. So this distance from point O to this over here, how much will it be? The radius of the semicircle is L by 2. So this is L by 2, this is L by 2. So this is nothing but L basically. So from here to that particular point O is L. What you need to do is join the endpoints of that wire and figure out what is alpha and beta. For finite wires, the formula comes in terms of alpha beta. So the magnetic field due to a straight wire is mu naught current divided by 4 pi into the distance, which is basically L, into sine of alpha plus sine of beta. As you can see, the point where you are finding the field when connected to the first endpoint makes 0 degrees with the perpendicular drawn. The perpendicular drawn and the line joining the endpoint, they are coincident. So there is no literal angle, so sine 0 degrees. Whereas this line joining the point till the endpoint with the perpendicular drawn on the wire, how much angle will it be? This is L, this is L, this is obviously 90 degree. This is kind of obvious now. This is obviously 45 degrees. So the other angle is 45 degrees. Sine 45 is 1 by root 2. So mu naught I by 4 pi L, sine 0 plus 1 by root 2 will make it just 1 by root 2 over here. And which direction will it be? Hold your thumb in the direction of the current. The fingers will curl like this. So at this point, the magnetic field is going basically inside. So hence, it will be minus K cap. Is that absolutely clear, everyone? Yeah? Pakka? Very good. Amazing. Next, what do we do? Let's take this particular part of the wire. It's a arc. So magnetic field due to the semicircle will be given by mu naught into current divided by 2 times of radius. Radius is L by 2, but it is for a circle. For a semicircle, it will be half of that circle. So this formula was for a circle. So I just need to multiply half with it. And if you curl your fingers along the current, the thumb will go inside. So the magnetic field is obviously inside. So it will be 2 cancels. So it will become mu naught I by 2 times of L with again negative K cap. Last thing over here is this quarter of a circle. This quarter of a circle, the current is going like this. So the magnetic field due to the quarter circle will be mu naught I by 2 times of radius. Radius is now L by 4. It has been marked over there as it is. And it's a quarter of a circle. So whatever contribution it will give, it will be 1/4 of the entire circle. So this formula was for an entire circle. So I will contribute exactly 1/4. So that will make it mu naught, 4 cancels, I by 2L, again negative K cap. Is this point absolutely clear, my dear warriors? Yeah, very good. So now what do you do next? All the magnetic fields are in the negative K cap direction. So the net magnetic field at point O, when you add all of them, will 100% have negative K cap in the answer. Mu naught will be common. I will be also common. In fact, pi might not be common, but L will be common, of course. And over here, you will see 4 pi root 2 there. 4 pi root 2. 4 pi root 2 over here. And over here, you will see 1 by 2 plus 1 by 2. So you will have 1 by 2 plus 1 by 2 and with negative K cap. 1 by 2 plus 1 by 2 is basically 1. So when you take it as the common answer, you are going to say 1 plus 1 by 4 root 2 pi K cap with a negative sign mu naught I by L as it is. Yes, this is exactly what we were expecting. So mu naught is there, current is there. You can see also L is there. And over here, you will have 1 by 4 pi root 2 plus 1 with a negative sign over here, and you can put K cap. Same thing, negative K cap here or there, one and the same thing. Is that right, everyone? Yeah. So answer will be negative. You can see, in fact, all the options are negative. So, JEE Advanced paper setters are also very smart. They know people try to eliminate and they will eliminate two options. Many people will not even calculate. They will just see the direction. But what will you do in this? All the options have negative k. So, your tricks, your shortcuts, your tukka strategies never work in JEE Advanced. Very rare, but too, it's very difficult to find it. So you have to go through the process, and that is why concepts become very, very crucial. Is that okay, everyone? Shall we go ahead to the next question then? Okay. This is the next one. It says there is a rectangular loop of side A and B, and it is placed in a XY plane. Okay, there is a loop in XY plane. A very long wire is also placed in that same plane such that the length A is parallel to the wire. Okay, the distance between the wire and the nearest edge is D. Mutual inductance is proportional to. That means you have to find mutual inductance. You have to draw the diagram and you need to figure out what is the way to find mutual inductance. Okay, let's draw the diagram first. So this is that long wire which is carrying some current. Let's say the current which it is carrying is, let's say, I. It will generate a magnetic field around it. There is a rectangular loop placed in the same plane such that the edge A is parallel to the wire. So this is basically your A. This is basically your A, and the other side is B. So this is basically your B. And the nearest edge is basically D from the wire as given in the question. Now the logic to find mutual inductance is figure out the flux passing through that coil, loop, whatever, due to the current carrying conductor. If you are able to show that the flux is proportional to the current, if you are able to show that the flux passing is proportional to the current, you can get mutual inductance. It's that simple. So how do I find flux? You need the field and you need to multiply it with the area. So you'll be like, sir, magnetic field I can find, I'll multiply with the area. But then you will realize the magnetic field is not uniform. If you are here, it is strong, weak, and weaker. So the flux at every single point is different. So when you calculate the total flux, I have to account the magnetic field is varying, which means integration. Got my point? The magnetic field continuously is changing. So I cannot just multiply field with area, because which field will you take? You cannot just take average field. That doesn't work. So you have no other choice but to integrate. Okay, fine. Let's do that. So for that, what I will do, I will take a small strip of this figure, something like this, and I will assume that the strip is at some distance, let's say x, and due to the current carrying wire, at this point, the magnetic field will be inside, whose value is given by mu naught current divided by 2 pi x, and you will see that in that strip, there will be some flux which will be piercing. So that flux d phi will be magnetic field multiplied by the area. The magnetic field will be mu naught I divided by 2 pi into x multiplied by, see, if this is x, it's kind of obvious that the width of this will be dx. So the area will be height multiplied by breadth. Height is a and breadth is dx. So therefore, my total flux, which will be integration of d phi, will be mu naught I a divided by 2 pi integration of dx divided by x. Dx and x are variables, so it will be inside. Everything else are constants, so outside. So what might be the limits of integration? Obviously, my x will start from this point, which is at a distance of d, and it will go till here, which is at a total distance of d plus that b. So it will start from d and it will go to d plus b. So when I integrate, I will get mu naught a I divided by 2 pi This integration is log of x, ln x, yeah, 1 by x's integration is log of x. Higher limit first, so d plus b, and then the lower limit log of your d, and then subtracting both of them. So it will become mu naught a I divided by 2 pi, and this will be nothing but ln d plus b divided by d. Now, I think I am very close to my answer, because if I rewrite it like this, A over here, and I put I over here, it now kind of becomes obvious that this much part should be the mutual inductance, because you can see flux is always mutual inductance multiplied by the current. So the part which is inside is the mutual inductance, and you can see mutual inductance being mu naught A divided by 2 pi ln d plus b divided by d. And the question was, what is the mutual inductance proportional to A, B, 1 by d, or current? It can't be current, it is proportional to A. So answer is basically A. Definitely the right answer. Yeah. What a lovely question, guys. If you make a small mistake between A and B, you will get wrong answer. You will write B. Sometimes people write it proportional to current. No, flux is current proportional, but mutual inductance is independent of current. Remember that. So that is something which is very nice. Loving this question, guys. Yeah. By the way, a similar question had come in JEE Mains long time back, but yeah, this is also a tricky one. Okay. Match the following. Let's do this. Okay. Ready for match the following, my dear warriors? All right, everyone, spam the answer, spam the Josh, whatever you are feeling. Yes, sir. No, sir. Okay, sir. Spam it. We have a LCR circuit. This is the voltage. 45 will be the peak voltage. Omega will change. Resonant frequency is this much. Current is I naught. When the frequency is this much, the current is this much. Inductance is given. Match the following: I naught, quality factor, bandwidth, peak power. Looks like we have to find literally everything, because quality factor, bandwidth, all these things will require R, L, C calculations. VRMS will need, IRMS will need, or voltage into current will need. Maybe we'll need XL, XC, God knows. We might need a lot of things in this question. Okay, so let's literally find out everything. Okay, so I think I have a blank page, hopefully. Yes, I'll just create a duplicate. Okay, first things first. Since the resonant frequency is mentioned, and inductance is also mentioned, I know that omega naught is 1 by root of LC, and omega naught is 10 raised to 5 radians per second. L is basically given to me 50 millihenry. So 50 into 10 to the power minus 3 multiplied by the capacitance. So squaring both sides, this will become 10 raised to 10 is equal to 1 divided by, this is 5 into 10 to the power negative 2, 0 will get swallowed. So it will become 5 into 10 to the power minus 2 multiplied by C. So if I want to find capacitance, I'll have 1 by 5. 10 on this side will become 10 raised to minus 10, and this will become 10 raised to minus 2. So therefore my capacitance will become 1/5, which is nothing but 0.2 multiplied by, this will become 10 to the power minus 8. Well, if you want, you can also write the capacitance as 2 multiplied by 10 to the power minus 9 farad. Minus 9 farad, which is also 2 picofarad. That's the first thing which we get. Okay, great. Next important thing, during resonance, the current is I naught. During resonance, the current is I naught, amplitude wise. And I know that the current amplitude will be the voltage amplitude by Z, but during resonance, Z itself is R. And the voltage amplitude is clearly mentioned to me. It is nothing but 45. So 45 divided by resistance. Resistance is not given. Resistance is not given. Okay, this is done. Now let me go to the next part. What is it? When omega is changed, the current amplitude becomes this much. So when omega changes, XL and XC will change, and because of that, the impedance will change. Because of that, the current will change. So any current is basically the voltage divided by the nu Z. So that current has been given to be 0.05 times of I naught, and that voltage V naught is nothing but still 45, whole thing divided by the nu Z. Yes, this will be the nu Z. This is also the new current, by the way, the new current, not the resonant current. Z will be root of R square plus XL minus XC whole square. XL minus XC whole square. Now, what do I do? I naught value, I think I know. I naught is 45 by R. So I will just put 0.05 multiplied by 45 divided by R. At least I know in the next step 45 will get cancelled, but I'm still unhappy because I do not know what is XL and XC. Oh, but wait a minute. These are new X's and reactances, I can say. I have an idea. How about thinking how will reactances change with angular frequency? Maybe that will give me the idea. Yes, if I consider my old XL and old XC, they will be equal, obviously. Yeah, they will be equal. And it will be nothing but omega L. And omega, I already know, was 10 raised to 5, omega into L. L was 50 milli, so 10 raised to minus 3. So this will become 5 multiplied by, check this out, 10 raised to minus 2, and this is 10 raised to 5, so 10 raised to 3. So these many ohms. So XL, XC, which is omega L, will become 5 into 10 to the power 3 ohms. Earlier, resonant X's, these are. In the new scenario, because omega has changed, these X's will also change. So since XL is proportional to omega, the new XL, think how many times has omega changed? Well. See, look at this. The new omega as compared to the old omega is nothing but 0.8 times, because 8 into 10 to the power 4 is 0.8 into 10 to the power 5. So 10 to the power 5 and 10 to the power 5 is common. So it is 0.8 times. I hope you can see that right over here. It is 0.8 into 10 to the power 5 is your new omega, which is 0.8 times of the old omega. So that means my XL, because it is proportional to omega, will also be 0.8 times my old XL. 0.8 times my old XL. And how much is my old XL? 5 into 10 to the power 3. So this is 5 into 10 to the power 3. 0.8, you can write it as 8 by 10, which is also 4 by 5, which will make it 4 into 10 to the power 3. So that is my XL prime. Similarly, I also know XC is 1 by omega C. It is proportional to 1 by omega. It is proportional to 1 by omega. So XC prime will be old XC divided by 0.8. So old XC was 5 into 10 to the power 3. So this was 5 into 10 to the power 3 divided by 0.8, which is again 4 divided by 5. So this will basically become 25 by 4, into 10 to the power 3 ohms. This is your XL prime and XC prime. Substitute that over here, guys. No other option. Yeah, XL prime was 4 multiplied by 10 to the power 3 minus 25 by 4 into 10 to the power 3, and then square it. Solve this for R. You will get the value of resistance. You will get the value of resistance. How much are you getting the resistance as? Let me know quickly in the chat box. Yeah. How much are you getting the resistance as? Let me know in the chat box, guys. Okay. Because once that resistance is done, you can get the current and everything else. Because I think those were the options. Current is asked. Okay. Now quality factor, resistance is not asked. Bandwidth is asked. Peak power is also asked. So quality factor, bandwidth, guys, all these are standard formulas. Yeah. What is the formula for quality factor? Q. Yes, it is 1 by R and then root of L by C. 1 by R root of L divided by C. Substitute literally everything, guys. Inductance is known. It is 50 millihenry. So 10 to the power negative 3. Capacitance, I think we figured it out somewhere here. 2 picofarad. So 2 into 10 to the power minus 9. From that, you will get the quality factor. Last thing we need is the bandwidth. Bandwidth. Yes, what is the formula for bandwidth? What is the formula for bandwidth? Yes, come on, my dear warriors. Where did it go? The bandwidth of the circuit. Yes, we can write it in terms of quality factor only. We can write Q is equal to the natural frequency upon the bandwidth. The natural frequency upon the bandwidth. So which means my bandwidth will be omega naught divided by quality factor. Omega naught was 10 to the power 5. Quality factor, whatever I get, I'm going to substitute it over here. So that is also done. Last thing remaining is what? The peak power in resonance. Now, a lot of students will make a mistake in this. Average power will be Vrms into Irms. Cos of phi will be 1. Power factor in resonance is obviously 1. That is obvious. This is average power. But the peak power will not be RMS. It will be V naught into I naught into 1. So V naught maximum voltage is 45. I naught we can find it out from here. 45 by R. R you know from here. From that you will get the answer. Okay. Understood, guys, how to solve it? So after getting all the answers, you are going to get the B option. So P will go with 3, Q will go with 1, R will go with 4, and S will go with 2. Okay, these are the answers. Understood, guys? Yeah. 399, you can almost take it as 400, man, Lewis, if that is the scenario. All right. Let's go to some MCQs. I hope you understood the level at which the solution is. There are multiple stages, multiple steps. It is not like your mains match the following, tuck, 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 one option you get, other options you will get. No. Many times these could be matrix type. These options might also be not given to you. Yeah. Many times it might be just you have to bubble. P will mark with 1, 2, 3 or 4. You have to bubble. So you do not have this liberty many times. So be very, very careful. Okay. So in advance, you might not get options like this. You might directly be given a matrix table. So you have to mark in front of P, all options will be there. 1, 2, 3, 4. So you have to bubble the right thing. In front of Q, all the options 1, 2, 3, 4 will be there. So it becomes more complex than this kind of thing where elimination can be possible. Okay? Yeah. Yes, obviously, this will be way harder than what you do in mains. That's why it is advanced, and that's why time is consumed, and that's why nobody can complete the paper. Nobody can complete the entire paper, forget even 90% of the paper. It is very difficult. If you get 60-70% marks, you are in top 100, 500 kind of ranks. Okay? Anyways, moving on. Assuming that the nuclear binding energy per nucleon versus mass number is as shown. This is a very weird diagram. If you see, our usual diagram is something like this, right, in nuclear physics. But here the strange part is it is flat, then suddenly rises flat, then flat. Okay. Then fusion, fission will release energy. Okay, very good question, guys. Very nice question. Harsh, I will definitely tell you which questions you have to challenge, but in a separate session. So the analysis is going on. Our team is working behind the scene, and I will be cross-verifying. It will take some time, and I also will have to check everything. So maximum by tomorrow morning or tomorrow afternoon, I will let you know the questions. Okay, there is no hurry. We still have time till day after tomorrow. Today is 4th, 6th February is the last date. Yeah. Don't worry. By tomorrow, you can challenge. You don't have to challenge today. Okay. Now, fusion of two nuclei will release the energy. Okay. Just think about it. Why have they given this criteria versus this criteria? Why not directly from 1 to 100? Because if you remember your regular table, you might have seen whatever lower binding energy per nucleon elements are there, they undergo fusion and they become more stable to achieve higher binding energy per nucleon ratio. The problem is this flatness. Imagine an atomic mass number of, let's say, 49. Now 49 plus 49, what will happen? It will become 98. Now tell me whether it is 98 or 49, all these elements have the same binding energy per nucleon. So if that is the scenario, this has same binding energy, this has same binding energy, this has same binding energy per nucleon. So what will be the Q value of the reaction? It will be 0, because this curve is flat. That means it will release energy. Wrong, it will not release energy. Did you get this catch? So that is why this bifurcation is there. But just imagine you have atomic mass number 51, atomic mass number 51. Together you will get 102. This has higher binding energy per nucleon. You can see that 102, 101, all these have higher binding energy, whereas these have lower binding energy per nucleon. So immediately you will see the Q value will be positive. More binding energy means more energy is released. So the product has more binding energy, meaning more energy will be released. That means option number B is absolutely correct. This will release the energy. Q is positive. What a lovely question, no? Because kids will not realize this because of the flatness of the curve. It's a very special curve that they have given. So that's what JEE Advanced will test. It will test your concept, not what you have by hearted. What you have by hearted will be of no use over here. Now, similarly, if you talk about fission, from 100 to 200, will release. Okay, 100 to 200. Now, just imagine, even if you take, say, some element in, let's say, for example, 100 and let's say 60. If it splits into 80 plus 80, this 160 element has higher binding energy. This has higher binding energy per nucleon, whereas these have lower binding energy per nucleon. Lower binding energy per nucleon means they are relatively less stable. Higher binding energy means more stable. Do you think they will release the energy? No, right? It is becoming more unstable. So why will Q value be positive? Rather, the Q value will be in fact negative, because the products have lower binding energy per nucleon. So it will not release energy, it will definitely absorb the energy. But if you take 200 to 260, 200 to 260, so just imagine this elements right over here. Okay, say for example, 220 splitting into 110 plus 110. 220 has lower binding energy per nucleon versus 110 which has higher binding energy per nucleon. So the Q value for such a reaction will be positive, so it will definitely will release that energy. So B and D is correct and other options are wrong. Yeah, B and D are correct, A and C is incorrect. Yeah, understood guys how to solve this kind of question? Take an example. From this graph only you will realize whether it will become stable, unstable, whether energy will be released or negative or no change, depends on the Q value of the reaction. Got it? Yeah? Awesome, awesome. Okay, perfect, perfect. Yes, even D is correct. Perfect. Very good, man. Very good. Shall we go to the next question then? Coming up on your screen. Ready? 2027 aspirants. Wow. Who is that? Sishwar. Whoa. Looks like 2027, 2028 aspirants are more serious than 2026 aspirants now. What should I say? And the funny part is this is a class 12 based syllabus question. Okay. Yeah. So from modern physics, next question is there. Work functions are W1, W2, W3. Slope is asked. Ultraviolet light, will it be ejecting from which metal? Voltage cutoff, matlab stopping voltage versus 1 by wavelength graph is plotted. So everything is in nanometers. So work function ratio and all these things are asked. Now, in such type of questions, start with a generic formula if I can. Okay. Now, what happens is we all know that the energy of the photon is the work function plus E times the stopping voltage. So therefore, E times the stopping voltage is nothing but energy of the photon minus the work function. So stopping voltage will be energy of the photon, which is hc divided by lambda. This E will come below minus phi by E. So if I have to rearrange it a little bit, so I can write it like this. So it will be hc divided by E into 1 by lambda minus phi by E. Deliberately I have done it because you can see vertical axis is stopping voltage, horizontal axis is 1 by wavelength. 1 by wavelength. Be careful. So comparing, this is basically your x-axis, this is basically your y-axis. Naturally, this should be the slope and this much part should be basically C. So y is equal to mx plus C. So the slope is hc by E. Slope is hc divided by E. Yes, the slope is hc by E, where all are regular constants. So C option absolutely right. For work function and whether photoelectric effect will happen or not, I need to focus on this. Guys, this particular point which you are seeing, right, that happens to be the threshold wavelength corresponding point. So these points correspond to the threshold where the photoelectric effect will just occur. So for the first one, as you can see, 0.001 nanometer inverse is 1 by lambda naught. So think about it. Lambda for 1 threshold, we are talking about threshold. Lambda 1 will be 1 by 0.001, everything in nanometers. Yeah, because this was nanometer inverse, so this will be just nanometers. All right. So this is nothing but 10 to the power negative 3. So it will become 10 to the power positive 3 multiplied by 10 to the power minus 9 over here. All right. This is the first thing. So you can just probably write this, forget the nanometers, just write it nm and just write it as 1000 nanometers. So that is the first wavelength. Lambda 2, how much is it? 1 divided by 0.002 nanometers. So this is 2 into 10 to the power negative 3. So it will become 10 to the power 3 divided by 2 nanometers, which is 1000 by 2, which is nothing but 500 nanometers. Lastly, lambda 3. Lambda 3 is 1 divided by 0.004 nanometers. All these points corresponds to the threshold wavelength or threshold frequencies. In this case, it is 1 by lambda. Correct? Okay. So how much will this be? So this will be 10 to the power 3 divided by 4 nanometers. So 1000 by 4 is 250. So 250 nanometers. Now, if you ask me about ultraviolet light, violet I know is around 400 nanometers. So UV light, which is incident, is of the range of 400 nanometers and less, is approximately 400 nanometers and slightly less, maybe 350 nanometers, 390 nanometers. That wavelengths are ultraviolet light. Now compare that with the threshold. When will photoelectric effect occur? When the incident light has lesser wavelength than the threshold. 400 should be lesser than the threshold. It is only in this case. So photoelectric effect will occur here and here, but not here. Can you see why? Because 400 is more than 250. So when the light which is falling has more wavelength, that means it has less energy. So that is why it will not be able to emit photoelectric effect. So 1 and 2 is possible. 3 will not be possible. Yes, so D option is absolutely correct. Work function ratio. Well, that is simple. How can we do it? Work function is hc by lambda naught. So whatever is 1 by lambda, same ratio work function will be. So W1 is to W2 is to W3 will be in the ratio of 0.001 is to 0.002 is to 0.004. So this will be 1 is to 2 is to 4. So 1, 2, 3 ratio. Yes, 1, 2, 3 ratio will be in the ratio of 1, 2 and 4. That is option E. Got it, guys? So option number A, C and D are the right options. Yeah, I hope you saw that. Over here, this was nothing but hc into 1 by lambda naught. So it was indirectly proportional to 1 by lambda. All these numbers, remember, are 1 by lambda. All these numbers are 1 by lambda. Keep that in mind. All right, perfect. Amazing. Let's move to the next question, number 8 on your screen. I hope you also see that every question takes so much of time to actually discuss, solve. And yes, when I'm discussing now, I'm not giving you that time for thinking. Maybe in a recorded version, when you watch it, you can pause the video, think on your own, and then play, take a hint. Don't watch the entire solution. Maybe that's how you proceed. Because in the actual exam, maybe this might not be even the speed of all the students. Some students might proceed with the same speed with which I'm solving. Yeah, and also I'm taking some time to explain. But yeah, this is the level till which you will have to think to solve these questions. Next one. Object is there, convex lens is there, f1 focus, f2 is the secondary focus, image is formed at a distance of x2 from the secondary focus. Then transverse magnification x1 plus x2, x1 into x2. This sounds to me like the Newton's formula. If you remember Newton's formula, if all the distances are measured from the focal point for a concave mirror, then the product of their distances is the square of the focal length. How many of you remember this? Hi Shivam, welcome aboard. Yeah. So maybe we'll have to prove that in a way. So let's try to do that question. Now see guys, first things first, all the distances are measured from the focal point. So this distances on this side will be negative So this is positive, but in our real convention, we measure everything from the pole or the optical center. So technically, this is my image distance and this is my object distance. Needless to say, this is my focal length. Same thing over here, the secondary focus. So if I use lens formula, 1 by V minus 1 by U is equal to 1 by F. What is image distance? Image distance is F plus your x2. So this will be F plus x2 minus 1 divided by object distance is x1 plus F, but it is on the negative side. So that's why the minus sign. This is equal to 1 by F. I think we should solve this now. So I'll have 1 by F plus x2 plus 1 by F plus x1 is equal to 1 by F. Taking LCMs, so I will have F plus x1 into F plus x2. On the top side, F plus x1 plus F plus x2 is equal to 1 by F. Cross multiply again. F plus F is 2F multiplied by F is F square plus x1 into F is nothing but F x1. F into x2 will be again F times of x2. Nothing else is there. FF is 2F. Okay. Is equal to, when I multiply these, I will again have F square plus fx1 and fx2. Both terms will be there. Fx1 and fx2 will be there. And I'll also have x1, x2. So I'll also have x1 multiplied by x2. Couple of terms will get cancelled like fx1, fx1, fx2, fx2, f square, and this 2 will get cancelled. It will just become, therefore, f square is equal to x1 multiplied by x2. I think that was one of the options. Yes, so C option is absolutely the right one. Okay, correct? Everybody till this point? Okay. Now, I think this also I can get it easily. I'll tell you how. We know our AM more than GM property. I think that should give you an idea how we get it. How many of you, this idea clicked, sir, we have to use AM more than GM? For how many of you, this idea clicked that maybe I will need arithmetic mean more than equal to geometric mean? Arithmetic mean of x1 and x2 is more than or equal to geometric mean of x1 and x2. Why it clicked is because x1, x2 is f square. So root of f square this is. So this will be just f. So x1 plus x2 inequality is more than 2f. So that is your option number D also. So we got it from AM more than GM. So that is how maths can be used at random places in physics. Yeah? Loving that correlation, guys? Okay. But that is not all. We also have to figure out the magnification. Maybe both are correct. Maybe one of them is correct. I don't know. Let's figure that out. So for magnification purpose, I know magnification magnitude will be V by U magnitude. V magnitude is F plus x2. U magnitude is F plus x1. We are talking about only the magnitudes. Okay. Now, how about x2 and x1? See, guys, x2 or x1, if I have to substitute, x2 will be f square by x1. x2 will be nothing but f square by x1 and f plus x1 as it is. So taking f common, and here I have f plus x1. I have 1 plus f divided by x1, which is f divided by f plus x1. This will be f plus x1 in the numerator divided by x1. F plus x1 will cancel. So I'm left with f divided by x1. Crazy if you think about it. So the magnification is f by x1 is there, I think. F by x1, yes. What about option B? Well, let's think about it. So if my magnification is f by x1, and I also knew what I have done over here was x1 into x2 was f square. So all I have done is x2 was f square divided by x1. That's what I had done. So maybe it's time to substitute even x1 also. X1 will be f square by x2. So what I can do, f is as it is divided by x1, right? X1 is f square divided by x2. So ff will cancel, x2 will go on the top, x2 divided by f is also the magnification. So x2 divided by f is also there, I think. Yes, x2 divided by f is also there. So option B is also right. So in fact, all the options are correct. Yeah, the funny part is all the options are right. So you can get such kind of questions, and that will be one of the tricky questions. Keep that in mind. There is no guarantee there will be partial marking. If it is there, good. But if it is not, there might be even negative marking. Who knows? And JEE might be like, if you don't mark all the correct options, you will get -2 marks. And that will be one of the toughest MCQs then. Isn't it, guys? Yeah. Shall we go ahead to the next question then? Okay. I think this was the last question. Yes, I had planned for 9 questions. So this is the last question. As seen in this diagram, there is a semicircular metallic strip which has a thickness, resistivity, inner radius, outer radius, voltage which is applied, and a current I which flows in this part. And a transverse voltage develops between the inner and the outer surface purely due to the kinetic energy of the moving electrons. That means mechanical part. Ignore electromagnetism in that, the voltage part between the ends. Then which of the following is true? What about the current? Outer surface has higher voltage, inner surface has higher voltage, or okay, and the voltage difference is proportional to I square. So BCD, I think they are related to each other. This first part, current, how much current is flowing in the circuit might be related to the resistance of this strip, because I know the voltage, I know the current, what is the resistance? If I get that, my job is done. So if I have a diagram, okay. Now see guys, this entire diagram is simplified to just this. What is the resistance of it? Okay, what is the resistance equivalent of it? Because that current will be that voltage by the equivalent resistance. Okay, whatever that strip is there, equivalent resistance. So I think they have given the resistivity, if I'm not wrong, and inner radius, outer radius, and some thickness is also given. Okay, semicircular metallic strip and thickness is also given. Okay, so I'll tell you what. When the current enters over here, I want you to visualize this. It will now split into multiple branches. Like this, like this, like this, like this, like this, like this, like this. And these currents will go like that over here. Not showing all of them, but can visualize before they again merge back over here. Yes, before they again merge back over here. And each such current line feels like a conducting element of different lengths having different resistance rather. These all arcs feel like resistors which are connected between the ends in parallel. How many of you get that feeling, guys? Between these 2 points, it feels as if you have one resistance like this, one resistance like this, different resistances, and so on and so forth till you go to the last resistance like this. All these resistors are actually in parallel. So resistors in parallel. That means the equivalent resistance reciprocal will be 1 by resistance 1 plus 1 by resistance 2, but each such resistance, there will be infinite such parts. So I think it will be 1 by dr, and I have to integrate this. That is what it should look like. Yes or no? Come on, think about it. Yeah, can only one option come out to be correct in multiple correct? Yes, that will be also very tricky. And if such a question comes, many kids will feel very scared because they will think two times that have I missed an option, because they can trick you to only one option correct even in a MCQ. So I hope this logic is clear. There are multiple resistors. These are elemental resistors, elemental resistances, elemental resistances, meaning each of them will be dr like that, and 1 by that integration will be the answer. Is that right? For 1 by R equivalent. Oh, so this much logic if it is clear, now I will think of taking a random such resistance somewhere over here maybe. Okay, and let's assume the radius of that thing is x. I will not confuse it with r or else you will get confused. And it will have a cross section. It will have a cross section. Think about it. Cross section width into this thing, which is basically dx. So thickness into dx. Thickness because it has some depth. Yes, this semicircular strip had a thickness. So that is along the inside outside of the board. So the thickness is like this. Okay, think of the strip to be here. So, there is a thickness like that multiplied by the width. The width is dx. So that is the cross section of it. Okay, visualize that, guys. If you want, I will draw a diagram here again. It is something like this. Okay, so we have basically taken this small element over here like this. Now visualize this as the cross section. So where this is your thickness, this much is your thickness, and this is basically your dx. Okay, I hope you are able to visualize it now. Okay, now what might be the resistance of that? That is basically dr. It is resistivity into the length divided by the area, rho L by A. What is the area? It is basically T dx. What is the length? It is the semicircle's length, which is nothing but pi x. So therefore, my R equivalent, which was integration, sorry, my bad. Therefore, my 1 by R equivalent, my bad, which is integration of 1 by dr. So 1 by dr means it is rho pi x divided by t dx, which means 1, or rather thickness will go on the top, rho and pi will come over here, and integration of dx by x will remain. This is what 1 by r equivalent will turn out to be. But what will be the limits? Obviously, x will start with r1 and it will end with the final radius r2. So this will be r1 and this will be r2. So doing the integration, thickness divided by rho pi, 1 by x's integration is log of x. So this will be ln r2 and ln r1, and obviously we have to subtract both of them. So this will become t divided by rho pi ln r2 divided by r1. Log a minus log b is log a by b. But do not forget, this is 1 by r equivalent. So therefore my r equivalent will be the inverse of this. So it will become rho pi divided by t and then log of R2 divided by R1. But that's not the end story. I want the current, if I'm not wrong. So voltage divided by the equivalent resistance, which is rho pi divided by T ln R2 divided by R1. So my final answer for the current will be voltage multiplied by the thickness multiplied by log of R2 divided by R1, whole thing divided by rho into pi. That should be the answer for the current. Let's check out if I have such an option. Voltage into thickness by rho pi log R2 by R1. Absolutely the right answer. Can you see that? Yeah, same thing, I have got it. So the first option itself needed visualization, understanding of why they are in parallel, and then integrating it to get the final resistance by choosing the proper element. So that was the first option. Yeah. Is there a revenge NTA for this year? NTA has not taken literal revenge. It has just, leveled up the paper rather than making maths very difficult, chemistry very easy, physics easy to moderate. They have made maths moderate to difficult, physics moderate or sometimes difficult also, and chemistry easy to moderate level and very rare difficult questions. So they have, shifted that unbalance to something like this. Almost everything is near about moderate. Okay, but that is not the end story now. Now there is another problem. Surfaces having lower or higher voltage, and how is that voltage related to the current? Because they have mentioned one very important line. The voltage which has developed between the inner and the outer surface is purely because of the kinetic energy of the electrons. Because otherwise you might be thinking, why the hell is that voltage coming up? So let me explain that to you. If the current is going like this, it means the electrons over here, if you take the electron, that electron is going like this. So this is the motion of an electron. And remember, any electron obviously has a mass, has a charge. So if an electron is moving in a circular path, circular motion, yeah, it is having a circular motion. The circular motion obviously has some kind of radius. Let's say I call it x. Then that circular motion must definitely need a centripetal force, must definitely need what we call as the centripetal force. And who will give the centripetal force? Because it's a charge. Yeah, mass is there, but gravity is not the concern. It's a charge which will experience electric force, and it's a negative charge. So electric force, if it is like this, the electric field must be in this direction. So this is the direction of the electric field. Why is the field like that? Because a negative charge will experience a force opposite to the electric charge. Oh, so the electric field is radially outwards. So electric field is radially outwards. Radially outwards. We all know that electric fields always go from lower potential to the higher potential. Sorry, higher potential to the lower potential, my bad. So if electric field is going like this, if electric field is going like this, it becomes obvious that this is higher potential, and obviously this is lower potential. And because of potential, because of this, we can see there is a voltage difference. Yes, what is created now between both of them? There is now a potential difference which is created. Potential difference of delta V which is created. How many of you understood this now? So such a brilliant question, such deep thinking is there. So inner surface is at higher potential, that is what we get. So inner surface is at outer higher potential. Outer surface is at higher potential, outer surface is at lower voltage. So C option is correct. Obviously, B option will be wrong because the outer surface will be at lower potential. Okay, understood the logic behind it? Pure mechanics over here. So C option is also correct. Now, what is that voltage difference going to be? Okay, so the answer for that is voltage difference magnitude wise is integration of electric field with respect to x, because E is dV by dx. So voltage will be integration of E dx. I'm talking about only the magnitude. I'm not interested in the sign right now. So electric field, oh my god, how do I get that electric field? Think about it. How do I get that electric field? So for that, I come back over here. Electric field multiplied by the charge is the force. So force is equal to mass multiplied by centripetal acceleration. So force is charge multiplied by field, mass is m, centripetal acceleration is velocity square divided by radius, radius is x. Great. From this I am getting electric field to be m divided by qx and v square over here. But this velocity is the drift velocity. Wow, what a question, guys. We are coming to this velocity is the drift velocity, and we know I is equal to NV Yes, NVEA. So V is equal to I by NEA. So V is some constant multiplied by the current. That's all I need because I want proportionalities. So because it is V square over here, I can clearly see this will become M by QX V square. That means that constant square multiplied by the current square. So substituting all that here, see what I am getting. Crazy, guys. Electric field is M by Q into X. Constant square multiplied by the current square. Isn't it interesting? And finally, of course, we have dx. So obviously current square is coming out, m is also coming out, q is also coming out, constant square is also coming out, integration of, I have dx and x over here, but that is something which I don't need. I am just interested in what is the voltage proportional to. It is proportional to mass, inversely proportional to charge, also directly proportional to current square. This integration we can easily do. This will be from R1 to R2. So it will become log of R2 by R1. Yeah, that's logarithm, simple. But if you look at the options, log is not there. Voltage is proportional to current square is there. So D option is also right. You can see right from here that my voltage difference is directly proportional to the square of the current. What a question this is! From where we went to where? Circular motion, electrostatics, drift speed, electrostatics voltage and field relationship, concept of why it is acting first of all and why that potential difference comes. All this understanding is crazy and it makes a brilliant question. So ACD is the right answer. Okay, now if you are interested to learn more from Eklavya teachers, because these questions are just the trailer, guys, it goes on deeper and deeper and we solve more and more questions, more concepts. We have the Eklavya batch from JEE Mains to Advanced. Your journey, everything will be covered. And when I say mains, I'm not saying April attempt, I'm saying right from your January attempt till your advance, because now also you will be writing the April attempt. So when the April attempt exam comes, we will be helping you with that. But the main focus will be the JEE Advanced, which will come up in the month of May. So this has 100 plus classes, hours of classes with 100 plus hours of testing and more than 3000 questions. This today what we solved were just 9 questions. Imagine solving 3000 questions like this and developing the concept. Learning from the best teachers is what is going to make you crack IIT. So if you are interested, make sure you check out the link in the description box. Well, you are also going to get the advanced rank accelerator books, which has the best of the best advanced questions, non-PYQs, arranged topic and chapter wise with solutions, so that you don't have to waste money on buying books. Yes, the batch price looks crazy, but if you go down into the description box and click the link, you will see that there is an offer running because the JEE Mains first attempt is just over, and I feel you should be utilizing that offer to the fullest. So instead of paying 22,000, you will be barely paying 6,999 rupees for the combo batch. This is the entire batch without the hard copy. So both the differences have been mentioned, student testimonials, everything. The only difference between them is whether you want the books, the rank accelerator or not. Okay, hard copy. Yes, the batch is in pure English, physics, chemistry, maths, and you can see all the details have been mentioned right over here. Okay, the classes are going to start now, so you better enroll into it. Instead of paying 22,000 rupees, you are getting it at a very cheaper rate. Okay, yes, these are your rank accelerator books. Thank you so much, guys. Have a great time. Thank you for liking. Leave a comment below on how you enjoyed and did you love this session, and do you want me, your Captain Shreyas, who has been sending kids into IITs, to conduct more such classes on YouTube. Okay, because I know advanced crowd will always be less. It's not that I'll get crazy views and I'm doing it for views. I'm doing it because I enjoy personally solving these questions. Plus, I feel that many kids will be benefited from it. If you want that, like this video and share this video. Okay, and comment below. Okay, thank you so much. Captain Shreyas signing off.